hello everybody, my name is Viktor. I'm a third-year student of this department, and also I have already graduated from Oil and Gas University. So today I'm going to give you some essential and useful information about oil and gas industry. So please raise your hands who wants to work in oil and gas industry after university. Let me know how many people. Raise your hands. Gazprom, Rosneft. Okay, 1, 2, 3, 4, 5. I think that's majority. Thanks, guys. That's a great choice. And today I'm going to teach you in a simple way how to retrieve more oil from the subsurface and earn more money. Okay. So I forget some important things.
Can we change our specialty for earning money?
You would love. So,
okay. Sorry.
First of all, I'd like to explain you that oil reservoir is not a swimming pool. It's not a lake in the subsurface. Oil is here. What is that? That is porous permeable rock. I can take it to you. You can watch it, and as students, oil can flow here. This sample has a conductivity. So it's for your understanding. And today I'm going to tell you about hydraulic fracturing. Hydraulic fracturing is a special method of oil recovery stimulation by means of very high pressure. So several powerful pumps inject the fracturing fluid into the wellbore at a very fast rate. The fluid develops a high pressure that fracturally splits or fractures the rock. Every fracture has its geometry designed by frac engineers. It has its length, height, and width. So, to visualize this process better, imagine splitting a log with an axe. That is a log, that is an axe. The axe head is a wedge. A wedge first cuts a tiny crack into the log. Then the force of the blow enlarges into a wider cut until the log splits. The same principle in hydraulic fracturing. The fluid works as a wedge, and its high pressure is a force that pushes into the rock. Also, it's useful to say that hydraulic fracturing splits the rock instead of casing, because casing is much more stronger than the rock, and because it's made of steel and reinforced cement. So, there are several important stages in hydraulic fracturing. First of all, it's a pre-frac preparations. We need to clean this wellbore prior to frac by means of acid treatments or with solvents. So the objective of this cleanup is to improve the effectiveness of future frac operations. And by cleaning these perforations, these holes, our purpose is to get rid of different contaminants in the holes. The next stage is a mini frac. So the purpose of mini frac is to check the frac design parameters and check the correspondence with real situation in the well. If the results are good, we can go ahead. So also there are three important stages. So first of all, we need to set packers into the wellbore. Then we are going to run our work stream. It's worth to say that we need packers to seal off our target interval, and also we need work stream to pump our fluid. So the first stage is a pad. Gel fluid is pumped into the well at a very fast rate until the fracture breaks down here and here. The next stage is a main frac. We need to pump gel fluid and propans together to fill these fractures. And the final stage is a flush. We need to clean this wellbore. Our purpose is to get rid of propans, gel fluid, additives. Our wellbore must be clean. So, as I said before, first of all we use gel fluid. It's a stage pad. Pad is a fluid without propans. It creates a fracture. So you can see that fluid frac engineers must design formula of this fluid for each individual well. And you can see that it is thick, right? This fine liquid, because of different additives such as guar for creating viscosity and cross-linking for creating strong polymer chains. All of them are thickening agents. So, and now we understand that gel fluid, we need gel fluid to prevent water from reaction with clays, to prevent the friction between the walls of work stream and this fluid, and the main purpose, we need to prevent fluid loss. What is the fluid loss? So, fluid loss is a very undesirable process when fluid soaks into the rock. You can see that this sample, it is formation in the subsurface. We need to develop a high pressure between our fluid and this sample. But if our fluid will soak into the formation, we can develop a very high pressure. That is why fluid loss is a very important parameter in hydraulic fracturing, because it controls the length of the fracture. The longer the better. Ideally, we need to get to achieve a long fracture. That is why our purpose is to minimize fluid loss. So, as I said before, gel fluid must create a first crack into the formation. Then we need to pump propans. Propans and gel fluid together is slurry. So we need to pump propans in different concentrations. It depends on fracture, but usually it's low, medium and high. And now we understand that our gel fluid must not only break the formation, but also suspend propans like slurry and transport it to the fracture. So, why do we need propans? Propans, these balls, propans are needed to hold open the fracture when the fracturing is complete. Propans are needed when crew stops pumping and the hydraulic pressure released and the fracture tends to close. The same principle in situation when I describe you splitting a lock with an axe. When you want to remove an axe from almost splitted lock, the fracture tends to close. The same principle here in the subsurface. And also we must to select the most suitable propant for our well, which we need. So, and now I'd like to draw your attention to the frac equipment. There is a simple scheme. So, in order to carry out a frac job, we need a huge amounts of water and propans. They're here in these tanks. Then the propans, water, different additives such as guar, cross-linking, breakers are mixed into the blender. That is blender. Then the fracturing fluid develops through pumping system, that is pumping system with manifold to the well. Actually, it looks like this. That is a tremendous, I think. All the equipment is hooked up. You can see the same water tanks, blender, manifold, pumping systems. So, and finally, if you decided to apply for a frac engineer after my presentation, think about it twice. Do you think why? So if you are really interested in, you can ask me, and after my conclusions, I will answer you. So, and my conclusions, I think that hydraulic fracturing is very important technology in companies, in oil and gas companies all over the world. Successful frac treatment can increase the productivity up to 400%, and this method of reservoir stimulation I think is incomparable because it can increase the economic life of the field. So, thank you for your attention. Any questions are welcome.
You said that if I want to apply for a job of frac engineer, I should think twice. Why so?
think that the job of frac engineer is very stressful, and I think it can be compared to an air traffic controller, because it requires full concentration and taking huge responsibility. So I can explain you why. If the frac job is failed, the company loses millions of rubles. That is why frac engineers must come to the location and monitor the entire process for 24 hours a day. They work from control station 1. I can show you. That is control station 1. And they must notice when the pressure released. That means that fracture is created. And so again, if the job of frac engineers is failed, it can result in send-off, for example, which is a very big problem.
Okay. What is the send-off? What is the problem with it?
Send-off is a very undesirable process when large amounts of protons plug the formation. You can see it here. When lots of protons plug this interval and it can move, that's a huge problem. Sometimes it occurs because of wrong breakers, for example.
The breaker is? Breaker moves proton?
No, breakers is special additives such as guar for creating viscosity or cross-linking for creating strong polymer chains. But breakers are needed to break these polymer chains. I can explain you why.